Let's talk a little bit about some terminology used in association with probability. We're going to keep it pretty limited. So, in probability terms, an event is something that may or may not occur, something that could happen, usually something we're interested in happening. An outcome is what actually happens, and there's a whole range of outcomes. Typically, an event is either one outcome or a collection of outcomes. And then the probability is a measure of how likely a given event is. So let's take a look at a couple of examples. So the outcome could be the roll on a 20-sided die, right? 20 possible outcomes. The event is that we roll something larger than a 15, so a 16, 17, 18, 19, or 20. So it's a collection of 5 out of the 20 outcomes. The probability is 25%, meaning if we rolled multiple times, we expect the event to occur, a roll larger than 15, 25% of the time. Another example, suppose you're offering a new product or service at your business, and the outcome is the number of new customers in a period of time, a week, a month, whatever makes sense. And you're wondering about how likely it is that the outcome, the number of new customers, is larger than 100. Probability, let's say we figure out that the probability is 10%. That means we expect if we, out of all of the weeks or all of the months, 10% of the time we'll have more than 100. Notice here I'm using the word expect. It's not guaranteed to happen. It's just the probability suggests that this is what we expect to happen. So when we talk about probabilities, there's two types of probabilities. One is theoretical probability. This is based on first principles or some assumptions, whereas experimental probability is you've got some data which has the relative frequency of individual outcomes, and you use that to determine the probability. So let's look at an example. And the simplest example is a die roll. So let's say you're playing a game that involves rolling a 20-sided die, and something you want to occur requires you to roll something, get a roll that's bigger than a 15. The theoretical probability is based on having 20 possible outcomes, 1 through 20, and the assumption is that each outcome has an equal probability. The event, rolling something bigger than a 15, so that's a 16, 17, 18, 19, or 20, has 5 outcomes. 5 outcomes out of 20 outcomes, each equally likely, gives you a theoretical probability of 25%, 5 out of 20. Now, if that assumption isn't true, then it's a loaded die, and that gets into interesting questions as well. But let's hold off on that. Now, what about an experimental probability in the exact same situation? Well, let's say you roll a 20-sided die 100 times, and the result was larger than 15, 41 times. Then based on that data, you would expect the probability to be 41%. That's the theoretical, that's the experimental probability. Now, the reason that occurred is because 100 in the grand scheme of things is not very many, is not a large number of rolls. Right? But if you have lots and lots and lots of rolls and the die is fair, you'll expect that this experimental probability will get closer and closer to the theoretical probability. Let's illustrate. This website allows you to simulate a large number of rolls of 20-sided die. So I rolled a 20-sided die 100,000 times, and you can see all of the various outcomes from each roll. So let's look at show stats. This will show us our relative frequencies. Give it a minute. There it is. So this tells me how many times each roll occurred. Now notice, let's add up how many occurred, how often my event, 16, 17, 18, 19, or 20, occurred. So I added those numbers up, 5,044 plus 4,999, and so on, and I got an answer of 24,952. That means my event out of 100,000 times happened very, very close to 25,000 times, which would be 25% of the time. Moreover, We can even see what's happening for an individual outcome. The probability of an individual outcome, like rolling a 5, is one outcome out of 20, which is 5%. 5,000 is 5% of 100,000. And look, each outcome is very, very close to 5,000. So what this tells you is while small number for small number of experiments, your experimental probability and theoretical probability may be very far off. If you perform the experiment enough times, your experimental probability will look closer and closer and closer to your theoretical probability. In the next video, we're going to talk about how to write probability statements using mathematical notation.